Okay, in this video we are going to learn about molecular formulas, and these are the two molecular formula seminar questions. So a molecular formula, and we talked about this yesterday, remember, is a multiple of the empirical formula. The empirical formula is the lowest whole number ratio of elements in the compound. So we need to figure out, let's say the empirical formula was S2O. We need to figure out if our molecular formula then is S2O or if it is S4O2 or if it's S6O3. Okay, these are all multiples of the empirical formula, and that's what a molecular formula is. It tells us the exact amount of each element in the compound, not just the lowest whole number ratio. So we're going to first find the empirical formula, and we talked about that yesterday on how to find that. So you'll want to first take the percentages and change the percent sign to a gram sign, because we always assume that we have a 100-gram sample. So then 50.05 grams of it is sulfur and 49.95 grams of it is oxygen. And then we're going to convert that to moles using the formula mass that we get from the periodic table, because it's the same number as the atomic mass. Its unit is in grams per mole though. So we look on the periodic table for the atomic mass of sulfur and we find it to be 32.07 grams is equal to 1 mole of sulfur. And then 16.00 grams of oxygen is equal to 1 mole of oxygen. So I plug this into my calculator to see what that is in moles. So 50.05 divided by 32.07, and we end up with 1.56 moles of sulfur, and then 49.95 divided by 16, and we get 3.12 moles of oxygen. Our next step is to divide by the smallest amount of moles, which is the 1.156. So 1.56, 1.56. And so the sulfur ends up being 1. So S equals 1. And the O equals 2. So those are our subscripts. So our formula is SO2. Now that's our empirical formula. What we want to do now is find our molecular formula. So this is the new step. What you want to do is you want to take the molecular mass, which is given to you in the problem, and you want to divide it by your empirical mass. And that'll give you your multiple. Okay? Well, according to our problem, our molecular mass is 64.07. We can find the empirical formula mass by using the periodic table. So it's SO2 is our empirical formula, so 1 sulfur, which is 32.07, and then 2 oxygen, which are each 16, so 32, And I add that up and I get 64.07. Okay, so my molecular mass is 64.07 and my empirical mass is 64.07. So I'm going to divide those and I get a multiple of 1. So my empirical formula was SO2. Then I multiply each one of the subscripts by 1, which doesn't change it at all, right? So my molecular formula is also SO2. All right, our next question to do, same steps, is we need to find the empirical formula first so that we can find the molecular formula. And this time we're dealing with 3 different elements in one compound. And so remember, whenever we have percent signs, we want to automatically change that to a gram sign because we're assuming we have a 100-gram sample. So 75.46 grams of carbon, and the mass of carbon is 12.01. And then 4.43 grams of hydrogen, and the formula mass of that is 1.008. Now remember, we're getting those formula masses from the periodic table, and it's the atomic mass. It's the bottom number in each box. And then we have 20.10 grams of oxygen, and its formula mass is 16.00. So I plug this into my calculator. 75.46 divided by 12.01. Okay, so I found the moles of carbon to be 6.28 and the moles of hydrogen to be 4.39. And now I'm going to find the moles of oxygen, so 20.10 divided by 16.00, and I get 1.256 moles of oxygen. And now I want to divide by the smallest one, which is the moles of oxygen, so 1.25. And I'm going to plug that in, so 6.28 divided by 1.25, and we end up with 5. And then 4.39 divided by 1.25, and we end up with 3.5. And then we end up with 1. So remember, when we have a number, we end up with a number that ends with 0.5, then what we want to do is multiply it by 2 to make it a whole number. But if we're going to multiply this one by 2, we have to multiply all of them by 2. So what we end up with is our empirical formula will be H7, because 3.5 times 2 is 7, and O2. I tell you that your molecular mass is 318.31. 310, whoop, sorry about that. Our empirical formula would be C10, because 5 times 2 is 10. So now I want to find my molecular formula. So I have to find my multiple, because I need the molecular mass over the empirical mass to get my multiple. So I have to find my empirical mass. So there's 10 C's and they all have a mass of 12.01. So 10 times 12.01 gives me 120.1. And then hydrogen, there's 7 of them and they each have a mass of 1.008. So 7.056. And then oxygen, there's 2 of them and they each have a mass of 16, so 32.00. So I add that up, 120.1 plus 7.056 plus 32 gives me 159.156. So that's going to go on the bottom to find my multiple. 159.156, and then 318.31. Okay, so I plug that into my calculator and I end up with 2. So my multiple is 2, and I'm going to multiply each one of these subscripts by 2. So my molecular formula ends up being C20H14O4. So you can see finding a molecular formula is just like finding an empirical formula, except for it has one more step, and that one extra step is this right here, where we have to set up a ratio between the molecular mass given to you in the formula and the empirical mass, which you can find from your empirical formula. And it gives you a multiple then that you multiply your subscripts by.